Trigonometric graphs is one area which is very simple but tricky. Question number 5, November 2017. We are given f of x, which is a sine x, and g of x, which is a tan bx. And then 5.1, we are asked to find or to write down the values of a and b. Now, if we look at a, where a is, the effect is on the amplitude. So a affects the amplitude. And not only the amplitude, if a is negative, it causes a reflection along the x-axis. So to find the value of a, we come to the graph of f of x and check what is it that has been done to this graph. Now, to see what has happened, let's check on the amplitude of the graph. We can see that the minimum it is attaining is -1. And it will also imply that the maximum it will attain will be +1. So we are saying the positive sense of a is 1. But now, checking on the graph, the way we know the graph of y is equal to sine x, we know the graph is passing through 0, and then it attains its maximum. So the graph is like this, and then it comes down at 180 it's 0, and then at 225 it will be -12. So if we check what the relationship of these two graphs, we can see that this one came as a result of reflecting this. That means our a should be negative. So for 5.1, we are saying a is equal to -1. Now b is on the graph of g of x, and look at the position of b, where b is. B is multiplying the angle, so the effect of b is on the period. So b affects the period. So we can check at what interval is the graph repeating itself. We can see this shape, we can see it again here. So it's from 0 to 90 degrees. That means it is now repeating itself after every 90 degrees. So initially, we know the graph of y is equal to tan x is having period of 180 degrees. So what is it that has been done to this to get the period of 90? So we are now saying graph of y is equal to tan bx. It has a period which is equal to 90 degrees. So what is it that has been done? What is it that has been done to 180 to get 90? So we can just say, therefore, b will be 180 divided by 90, which will give us 2. So we are dividing 180 by 90 by 2 to get the new period, which is 90 degrees. All right, 5.2, you are asked to write down the period. the period of f of 3x. Now, our f of x is a sine x. So f of 3x, it means where there's x, we are going to put 3x. That is a sine 3x. We may not talk about a because a does not affect the period, but it is these three that affects the period. In the same way we have reasoned to get 2 is the same way we reason to get the new period. We know the period of the graph of sine x. Period is equal to 360 degrees. So period of f of 3x, we are going to divide 360 by 3, which will give us 120 degrees. That will be the new period there. And then 5.3, we are asked to determine the value of x in the interval x is greater or equal to 90 degrees, but less or equal to 225 degrees, for which f of x times g of x is less or equal to 0. Alright, so if the product of these two is less or equal to 0, that means the conditions that we may have here, this may be positive and this one will be negative for us to get something that is less than 0, or the opposite, this can be negative and this can be positive. And don't forget that the product can also be 0. That means it's either this f of x, which can be 0, or it can be g of x, which can be 0. So we have to check for all these possibilities in the interval 90 to 225. So basically, we are looking at this interval from 90 to 225. Alright, so if a graph, or if f of x is positive, it means it's above. So we are checking from here, we can see that g of x is above, that means g of x is positive and f of x is below. But for how long does it go? Because it is satisfying what we want from 90 degrees. One is above, one is below. So it goes until 135 degrees. This one does not pass because it's an asymptote. So we are saying this condition is met in the interval where x is greater or equal to 90 degrees, but strictly less than 135 degrees. Why are we saying strictly less than 135 degrees? Because the graph of g of x is not defined when x is 135. So we cannot say it's less or equal to. Alright, then passing this, remember we still have this part to look at. We can see that from 135, f is below, g of x is above. That means, this one is no more part of it. Okay, so both graphs are below. So we don't want that. Both are negative. It means they will give us something greater than 0. And then it goes on, and then at 180 degrees, they are both equal to 0. G of x is 0. Remember, on the x-axis, y is 0. F of x is also 0. So the product will be equal to 0. It means this one 180 degrees is also a possible value of this condition. So we are also saying x is equal to 180 degrees. So that is basically how you interpret this question and how you answer this question. We will keep working on more and more questions, maybe to open your mind.